Okay, so we're gonna start on the right side. So this is this blue section. This is the right atrium. This little wing area right here, that is the right auricle. Okay, which makes this the right ventricle. Okay. On the other side of the heart, you have the left atrium, which is pretty huge. It's this brown area, which makes this the left ventricle. They're both separated by valves. Between the right atrium and the right ventricle, you have the tricuspid valve. On the left side, you have the bicuspid valve, also known as the mitral valve. The valves are attached to the walls of the ventricles via these cord-like structures called the cord of tendonae, and they anchor at these ridges. Okay, these little muscles, these are your papillary muscles. Not to be confused with the ridges that are found on the surface of the ventricle walls. These are the trabeculi carneae. Okay. You also have ridges found in the right atrium. These ridges in the atrium are called the pectinate muscles. On the left atrium, the only place that you find the pectinate muscles is in the auricle itself. The outer anatomy of the heart is, this is the apex where the heart comes to a point, which makes this top part the base. Okay. Main veins that come into the right atrium are the superior vena cava, which is this large vein, number 14, and the inferior vena cava, which you're missing most of. Okay. You also have one more vein that dumps into the right atrium, and it runs along the coronary sulcus. The coronary sulcus is that groove that separates the atriums from the ventricles. So right in the back of the heart, you have this called the coronary sinus. That's number 29. So the coronary sinus, superior vena cava, inferior vena cava dump into the right atrium. The ventricles, when they pump blood, they will move through two semilunar valves. The right ventricle goes through the pulmonary semilunar valves into the pulmonary trunk, which will then divide into the right and left pulmonary arteries that will run to the lungs. The left ventricle goes through the aortic semilunar valve, which then the blood will flow into the aorta. And you have three sections of the aorta. You have the ascending aorta, the aortic arch, and then the descending aorta. Off of the aortic arch, you have three branches. You have the right brachiocephalic branch. Then you have the left common carotid branch, and then you have the left subclavial branch, okay, of the arteries. Just like you have arteries going away from the heart, you have veins coming towards the heart. So all the veins that are headed in will either dump into the superior vena cava or the inferior vena cava. The only branches that you need to know are in the superior vena cava, which is the right and left brachiocephalic, and so they will merge into the superior vena cava. Right off of the aorta, you have two main coronary arteries. So you have the right coronary artery and the left coronary artery that runs beneath the pulmonary trunk. As it comes out, it branches, and so the left coronary artery branches into the anterior intraventricular artery. And this branch right here, you see that it circles around the heart. This is the circumflex artery. Let's see. Between the pulmonary trunk and the aorta, you have this structure right here, which is a remnant of when you were in the womb. This is the, what is this? This is the ligamentum arteriosum. The other remnant from when you were in the womb is this structure right here, number 55 on this model. That is the foramen ovale. So that's between the walls of the two atriums. That used to be open, used to be a foramen, I'm sorry, and now it is the fossa ovale. In the right atrium, wherever the electrical signal begins for pumping is right here at 32, is the posterior wall of the right atrium. That is the SA node. The signal will then travel down to number 33 down here. This is the what node is that? The AV node between the atrium and the ventricle. So the signal goes from 32 down to 33, and then it will eventually travel through the septum down here. These are the bundle branches. When it gets to the apex, then it will transfer over to the Purkinje fibers and cause the contraction of the ventricles. Let me see what else. The only other structure you need to know is this is the trachea, this is the esophagus, and I believe that is it.